So eliminate all distractions. We started the class already. So let's look at the structure of water. I see the structure of water. Water have this structure. In the structure of water, we have 1 atom of oxygen and 2 atoms of hydrogen. Okay. Water has 2 lone pair of electrons. Water has 2 lone pair of electrons. You can see 2 lone pair of electrons. And the bond angle between, you can see the bond angle in this water molecule is 105 degrees, approximately 105 degrees. You see the structure of water, we call it bent shape. Bent, or we call it V shape. That's the shape of water molecule. Shape of water molecule is what? Bent or V shaped. Some people can even call it angular shape. Are you there? Bent, V, or angular what? Or angular shaped. Now pay attention that the chemical bond between oxygen and hydrogen in this water molecule is covalent. You see this bond is a covalent bond. Is a covalent what? Is a covalent bond. Now pay attention. Remember that our covalent bond have to do with sharing of electron between 2 atoms. That means the word covalent. It's just like you want to eat with your friend. You brought food and your friend brought drink. So that's kind of your sharing. That's covalent bond. But pay attention to something. You might have learned this concept called electronegativity. What's electronegativity? It's the ability of an atom to attract shared pair of electron to itself. The ability of an atom to attract shared pair of electron to itself. Let me give you an example of electronegativity in a real life sense. It's just like you are dragging a cloth with your younger one. Let me say you are trying to dress your younger ones up and they don't want to go to school. Now check something out. To drag that clothes effectively. Is it you or your younger sibling? It's you. You have more power to drag the clothes. Now, that power you're using to drag that clothes from your younger one is what we call electronegativity here. Like I have electron between oxygen and hydrogen. They are not dragging it. The electron will fall towards oxygen. Yeah. The electron will fall towards oxygen. Why? Because oxygen is more electronegative. Now, because electron falls towards oxygen very well, oxygen acquires what we call a partial negative charge. It means that it is gaining more of the electron. That is, it is acquiring more of the electron. While hydrogen acquires partial positive charge. You see these charges that you are seeing in water molecule makes water molecule a polar solvent. Makes it a what? Polar solvent. Please, in a layman language, if you hear the word polar, it means we are having 2 poles, positive and negative pole. Are we together? In magnetism, we say north and south pole. But here, like electricity, we say what? Positive and negative pole. So water is a polar solvent. You can see polar solvent, good. And the bond between oxygen and hydrogen in a water molecule is called covalent bond. Now, because water is polar, we call this polar covalent bond. You can see a charge here, polar covalent bond. Good. That's that for that. Now, I still have something to say. Please, I still have something to say. Now, let's look at this structure. This is water. Let's look at another structure for water again here. This is another one. And don't forget, water has this lone pair, 2 lone pairs of electron. Good. Now, between 2 water molecules or between 2 or more water molecules, let me draw one more here. Between 2 or more water molecules, between 2 or more water molecules, yeah, there is, you can see that this one water molecule, this another water molecule, this another water molecule. Now, the bond between this molecule, that's what we call intermolecular force. The bond between this molecule, we call it intermolecular force. Now, pay attention. Don't forget that oxygen is negative, negative, negative. While the hydrogen is positive, positive, they are all positive. But don't forget this particular law in physics that states that unlike charges we always attract. How many of us can remember that? Good. Unlike charges always attract each other. It means that there will be an attraction between this and this. Are you there? There will be an attraction, you can see, between this and this. That's between oxygen and hydrogen in each of them and so on like that. Now, you see this intermolecular force that you are seeing here is what we refer in chemistry, we refer it to as what we call this bond that you see here, we call it hydrogen bond. We call it hydrogen bond. Now, let me now summarize what you need to know. We call it hydrogen bonds. Now, this is the bond between water molecule. Now, please pay attention. Let me now summarize something for you. From beginning, let's summarize. Let's summarize. That is what you need to know as JAM student. Let's summarize. Is that in the structure of water molecule has, you can just jot this down. Water molecule has two lone pairs. Where are the lone pair? This is one lone pair, this is another lone pair. So water has two lone pairs. And how many bonds do you see in water? Look at the bond. Two bond pairs. Water has two lone pairs and two bond pairs. Good. What's another point that we've learned from here? The bond angle. The bond angle in water molecule is what, guys? The one angle is water in water molecule is what? 105 degree. And the shape of water molecule is here. Bent, V shape, or angular shape. Good. So the bond between oxygen and hydrogen here is covalent bond. You see, if they ask you, they always ask this question, that the bond between water molecule is what? And what is the bond within water molecule? These are different questions. Now look at it. Look at two questions there. What's the bond between water molecule and what's the bond within water molecule? And that will lead us to what I've been explaining since morning. Now pay attention. The bond between water molecule is what? Now check. Look at one water molecule. Look at another water molecule. Now, the bond between this water molecule is this intermolecular force called hydrogen bond. The answer to this one is what? Hydrogen bonds. Hydrogen bonds. Good. That's the bond between water molecule. Please, that's another thing for you to jot. The bond between water molecule is the hydrogen bond. Is the hydrogen bond. Now, if they now ask you, what's the bond within water molecule? You know, if I use this English and say, within the school premises, have you gone out? No, you are inside. It's mean that they're asking you, what's the bond inside this just one molecule? That's what covalent bond. So our answer for this one is what? Covalent bond. If you want to be more specific though, you can say polar covalent bond. There's no problem. But options, mostly what you will see is covalent bond. Okay, nice. Aha, the bond between water molecule is hydrogen bond. The bond within water molecule is covalent bond. It's covalent bond. Nice. And then you see, from this thing, they can ask you many questions from what is on this screen. You remember that? Who knows? Who can still remember that? The boiling point of water, pure water, 100 degrees Celsius. Why is the boiling point of water so high this way? Why is it higher than some other compounds like that? Why is the boiling point of water high? It is due to the presence of hydrogen bonds. Yes. This hydrogen bond is a strong intermolecular force of attraction that holds water molecule together. So water has high boiling point due to the presence of what? Hydrogen bonds. Good. Nice. 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 Also, water is called what we call universal solvent. Universal solvent. We call water universal solvent because have you ever heard of a blood group called AB, universal recipient? What does that mean? Universal recipient means that it can receive blood from anybody. That's why they put the word universal. So this universal solvent means that it can dissolve many substances. Good. It can dissolve what? Many substances. And that is the introduction to water. From the introduction, thousands of questions can be asked. Please take know that. Okay, I'll send this note to us and make sure you jot the important points. So that is for that. That is for that. That is for that. Okay, let's go. Remember, we have different sources of water. I'm not meant to teach you this. Let me just talk about it. We have rainwater, spring water, river water, well water, and so on like that. All these, all these are natural sources of water. And the purest of them is rainwater. Okay, although it contains some impurity, because when it's coming from the sky, it's to contaminate. Different impurity can contaminate it. So that's why we also learn about treatment of water. So that's for that. All those things are small from primary school students. Now let's go. What are the physical properties of water? Okay, what are the physical properties? What are the physical properties of water? What are the physical properties of water? H2O. Well, all these are just simple. Remember that what water is colorless, odorless, and tasteless. That's pure water. Pure water is what colorless, odorless, and tasteless. Okay, good. If any of these can be affected, it means that the water is not pure. If the water should have different color or odor, or it has a kind of taste, then it is not pure again. Next, we have what we call, water has, what we call litmus paper. Everybody knows what we call litmus paper. We have red and blue. We use it to test if something is acidic or basic. Looking at water, water has no effect on litmus. No effect on litmus paper. Water has no effect on litmus what? Paper. Yes. That's why the pH of water is equal to 7. 7, neutral. Something that is neutral has no effect on litmus paper. It has no effect on litmus paper. Good. 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 Well, and so on like that. You see, under the physical property of water, we will discuss the test for water. You see, there is a way. You know that you can enter the lab and just see something that looks like water. You can't risk yourself to say, let me test this thing. If it is water, you can go and drink acid, and that will be hazardous. So we can't risk ourselves to test. What do we now do? We carry out tests for water. And please take note of something. You see, this test for water only determine the presence of water, but it does not determine the purity level of water. Let me use small English to say it. It can just tell us that yes, water is present. No, water is not present. That's what it can do. But this test cannot tell us if the water is pure or not. It can only determine the presence of water, but not the purity of water. Take note of that. Good. Now, we have 2 reagents for testing for water. What are they? We have white anhydrous. White anhydrous, copper 2 tetraoxosulfate 6. Anhydrous means powder. White powder, yeah. Another word for anhydrous is powder, if you need simple English. Also, blue anhydrous cobalt 2 chloride. Cobalt 2 chloride. These are the 2 reagents for testing for water. Now, what happens? See, if these reagents come in contact with water, H2O, what happens? It turns blue. It turns blue. That is, if you add water to white anhydrous copper 2 tetraoxosulfate 6, what color will it give you? Blue. White to blue. Now, the second one, look at blue anhydrous cobalt 2 chloride. If you add water to this guy, what does it turn? Some of us know the answer. Who knows the answer? Who can try this thing? Do anybody know the answer?
Pink.
It's a turn to pink. Thank you.
Thank you.
Nice. You can mute your mic. It's a turn to pink. So you can see it's very easy. From the first one, it's white to blue, blue to pink. White to blue, blue to pink. Exactly. White to blue, blue to pink. Jump ask these questions, so please take note of that. Okay. So that's the physical property of water and the test. Nice. So we want to discuss the chemical property, where you have to pay more attention also. Let's look at chemical property. Now, let me tell you something. You see, there are some metals that are highly reactive. There are some metals that are what highly reactive. We group them into potassium, sodium, and calcium. You see these metals that are here? You see, whenever we want to react them with water, you see, they are very reactive and they react explosively with water, most especially potassium and sodium. In fact, potassium can catch fire with ice block. Like all these are enemies of water. So the reaction is not expected of you to be trying. So it's very dangerous. So we always react them with cold water. We always react them with cold water, okay? And if you react them with cold water, what do we always get? If you react any of this with cold water, what do we always get? We always get, I'll give you an example. We always get alkalis and hydrogen gas. Let me give you an example. Let me say calcium reacts with cold water, H2O. Yeah, calcium is less violent, but the one for sodium and potassium, you will see fire. So when this and this react, we have an alkalis, CaOH2, then hydrogen gas is given off. This is a gas that is being liberated. Hydrogen gas is what is given off. Now you see this gas, let me tell you something. This hydrogen gas is given off. And how do we know hydrogen? How do we test the presence of hydrogen gas? Hydrogen gas is that gas that gives a pop sound with a lighted splint. With a lighted what? Splint. Yeah. Let me use small English to tell you. Carry your matches, light it, put it in a test tube that has hydrogen gas. In a place that is very silent, you hear a pop sound, very faint sound. Then that shows that what? Wow, hydrogen is present there. As simple as that. So when highly reactive metal, when they react with water, cold water, an alkaline solution is being produced, then the gas that is being produced alongside is hydrogen gas. And this reaction is highly exothermic. Yeah, highly exothermic, good. It releases heat. And so on like that. That's when reactive metals, when they react with what? Water. Okay. Now, that's for reactive metals. Now, let us now look at another one. All these ones are moderately reactive metal or semi-reactive metal. Just call it moderately reactive metals. Moderately reactive metal. This one, we group them into, we have magnesium in this group, aluminum in this group, zinc in this group, and iron. Magnesium, aluminum, zinc, and iron. Yeah, all these one, they are not as reactive as this first metal. Then they always react with steam. In fact, they cannot react with either cold or hot water. They will react with steam. Are we together? When they react with steam, they will give oxide of metal and hydrogen gas. You see, question can come out of this place. So let me show you one differences between this reaction. If we use any of this highly reactive metal with cold water, an alkaline solution is being given with hydrogen gas. But if you are using moderately reactive metal, any of these, magnesium, aluminum, zinc, and iron, they react with steam. Do they produce alkaline solution? No, they'll produce what? Oxide of the metal. They produce oxide and hydrogen gas is given up. Let me give you an example. Let me say magnesium plus water. What would that give me? It will give me what? MgO plus H2. See, I have oxide and hydrogen gas is being given off. That difference between them. Highly reactive metal will give us alkaline solution, while the moderately reactive metal will give us what? We produce oxide, the corresponding oxide of the metal. As I use magnesium now, I have magnesium oxide. If I use aluminum, I have aluminum oxide. If I use zinc oxide, and so on like that. So I believe all these are very, very clear. But there are some other metals that all these ones are the least reactive metals. The least reactive metals. All these ones don't react with water at all. The least reactive metals. All these ones don't react with water at all. Yeah. Example, I have lead, I have copper, I have mercury, I have silver, I have gold, I have platinum. All these cannot react with water because they are least reactive. They are least reactive. They are least reactive. Yeah, that's their reaction with metals. That's their reaction with metals. I believe it is clear. If you have questions so far, let me entertain question before I move to the next reaction. Any question? I'll be giving us 10 seconds. If I do not see any reply, then we move. Okay, good. It means that the lecture is very clear. I'm happy about that. Nice. Next, we want to look at the next reaction, which is the reaction with non-metals. You see, JAMB bring out question from all these points. There are no students don't read all these parts, so JAMB now bring out questions from them. Reaction with non-metals. Now look at something like this. Now pay attention. Okay. Pay attention. Look at this compound, SO2, SO3, CO2, and so on like that. There are many, but I don't want to give you many. All these that you are seeing here, they are called acid anhydride. Acid anhydride. Pay attention. Look at this compound. We call them what? Acid anhydride. We call them acid anhydride because when they dissolve in water, they produce acid. When they dissolve in water, they produce acid. And look at it. If I have SO2 plus H2O, that gives me H2SO3. This is an acid. This is what? This is an acid. You can see how they react. This is what? This is an acid. Good. Look at this one. SO3 plus H2O. What do I have? I have H2SO4. This is also an acid. This is also an acid. Yeah. This is also an acid. And so on. And so on. Please, I'm coming. Okay. And so on like that. You can see, firstly, when water reacts with acid anhydride, acid is being produced. So that's for that. Also, pay attention to this. Water can also react with oxides of metals. I'm coming, let me write. Oxides of metals like, let me see, Na2O, CaO. All these are called what? Oxides. Oxides of metals. Oxides of what? Of metals. When water reacts with oxides of metals, what do we get? We get what? Alkalis. An alkaline solution. Yeah. As simple as that. All these are very simple, but I don't have to give us so that we'll get it. Okay. Also, water can react with non-metal like, let me say, carbon. If I pass, see, look at this thing. Passing steam over white hot carbon. Passing steam over white hot carbon. What do we have? See, this is steam. H2O gas. This is steam, H2O gas. If I pass this steam over white hot carbon, what do we have? We have CO and H2. Who knows? This combination of CO and H2, what do we call it? Who knows the combination? It is called the name. CO and H2 is called the name together. Who knows that name? Hello, who knows this name? Anyone? Passing steam over white hot coke, I have CO and H2. What's that CO and H2 called? Wow, no one knows. And it's very famous too. Okay, I'll tell us the answer. This combination is called water gas.
Wallah.
Hey, Richard, walai. You don't know the answer before, Abi? Thank you very much.
Olodo.
So if you pass steam over white hot coke, we have CO and H2. CO and H2 both together, we call them water gas. Please don't forget. So water gas is a mixture of carbon dioxide and hydrogen gas. So and so on like that, and so on like that. There are many of them, but these are like the one I feel that are very, very okay for you to learn. Okay, good. Aha, please. I'll send notes to us so we can judge them properly. Nice. So we've learned all this, we've learned all this, we've learned all this. Well, other things about water you'll be learning in physics, about the boiling point, how it does not expand or contract regularly, and so on like that. Okay, good. We all know that water has some important uses. What are they? There are many important uses of water. It is used for agricultural purposes. That's for those that are farming, irrigation process, and so on like that. Industrial process, water is very important. In fact, domestic uses, water is very important, and so on like that. Now, we all know that water can never be 100% pure. There will be one or more impurity in water. Everybody knows that. There will be one or more impurity in water. So that is why we must learn treatment of water. Let's look at treatment of water. Treatment of water. Treatment of water for town supply. For town supply. Treatment of water for town supply. Treatment of water for town supply. Okay, please pay attention to something. Please jot whatever I'm giving you. Now, remember that water will surely have impurity. So, the first thing we do when we are treating water is aeration. Aeration and sedimentation. Aeration and what? Sedimentation. Good. You see, during aeration, what do? We expose the water to air and sunlight so that gases like CO2 and H2S present in the water can be removed on exposure to air and sunlight. So we do aeration so as to what? Make this impurity, this gaseous impurity. So we remove them on exposure to air and sunlight. We remove them on exposure to what? Air and sunlight. Are we there? So when we place it down, all those solid particles in the water can sediment. We can have something like stone, sand in the water. All of them can settle down. So the first step is aeration. So this is like preamble. Now the next one is coagulation. The next one is coagulation. The next one is coagulation. Now, what are those chemicals we usually add to carry out coagulation? The chemical are potash alum, We have potash alum. Potash alum, the formula is KAlSO4 2. This potash alum. Okay, KAlSO4 altogether. Yeah. This potash alum. And we have sodium dioxoaluminate 3. Sodium dioxoaluminate 3. This also used for coagulation. If we say coagulation, what does it mean? That is to make the particles suspended in water clump together. That is to make those particles clump. The clumping is what we call what? Coagulation. Okay. All right. So please take note of these two chemicals. Don't forget that. So aeration, exposing them to sunlight so as to remove the smell of these gases. Okay. Aha, good. Okay. Next, I. There are like deeper explanations to all these, but since we are looking at JAMB, we are good to go with these short explanations. Next one, we have filtration. Next one, we have filtration. Well, what do we use for? We use sandbed. We use sandbed to carry out filtration. We use sandbed to carry out filtration. We use sandbed to carry out what? To carry out filtration. Good. You see, in the sandbed, we always have some layers of charcoal. You see those layers of charcoal, they are to remove coloring matter. You see, charcoal is to remove color. To remove what? To remove color. Those coloring matter that I tend, you remember that pure water must be colorless. So we always add charcoal for what? So that it can remove, we can to remove what? Color. Okay, good. So that's filtration. The next one is disinfection. Disinfection. Now, this is where we want to kill germs. This is where we want to what? Kill germs. Now, pay attention. For us to kill germs, we add chlorine. Chlorine is added to kill germs. Chlorine is added to kill what? To kill germs. It has to be in calculated amount. Yes, it has to be in calculated amount. If not, it could be dangerous. Chlorine is dangerous. Yes, very dangerous. Good. So we add chlorine to kill germs. Also, we add iodide salt. We add iodide salt. Iodide salt is to do what? To prevent goiter. To prevent what? Goiter. Don't forget that what in biology, we have a particular gland that is located at the neck region, and that is called the thyroid gland. There's an endocrine gland located at the neck region called the thyroid gland. The thyroid gland is responsible for the synthesis of what we call thyroxine. Okay, and the thyroid gland actually needs iodine to synthesize thyroxine. So if it lacks iodine, what do you have? It causes goiter. The one Yoruba call gege. Yeah, that's goiter. Aha. And so on like that. And so on like that. So also, fluoride salt is added. Fluoride salt is added to prevent tooth decay. To prevent tooth decay. This one you see it in your toothpaste very well. To prevent what? Tooth decay. And what is being added again? CuSO4 is being added to prevent the growth of algae. To prevent the growth of algae. Have you ever asked yourself why swimming pool, the water in swimming pool always appear bluish in color? I don't know if some of us have gone to swimming pool before. Because some of us has gone to swimming pool to enjoy ourselves. Have you ever observed that toilet is something like this bluish color? Yes. They have added CuSO4 so that those greenish substances that always grow in stagnant water won't grow inside. So this CuSO4 now is being added to prevent those green substances, those algae, prevent it from growing inside it. So that's it. So these are the chemicals we use for disinfection. Let's revise it. Chlorine is added to kill germs and bacteria. Iodide salt is added to prevent tooth decay. Fluoride salt is added to prevent iodide salt is added to prevent goiter. Fluoride salt is added to prevent tooth decay. Copper 2 sulfate is added to prevent growth of algae. Now, you observe that if you drink some water, most especially the one produced in this Nigeria, may God save us. There's some water that you see. I want to discuss something here called the pH measurement or pH adjustment. There's some water that you will drink, it will be bitter. Yes. So we always use something to adjust the taste of the water, or we say to adjust the pH of the water. And that is what quicklime. Okay, that's quicklime. Quicklime is added, CaO. Please don't forget, quicklime is added to adjust the taste of the water. Okay, quicklime is added to what? Adjust the taste of the water. Then when all these things are done, therefore, this water can now be passed to our community. Now it is safe for drinking. There are some countries whereby you see the water you use from your bathroom, your toilet, everything is still the one that is being recycled back for you very well. In some countries, most of these countries that are like, let me say like Kuwait, those desert countries exactly, where water always, not abundance in this area of Nigeria, in this area of the world rather. The water they use are still the one that they still cycle back for them. Okay, those your water, the one you use in your bedroom, your toilet, your dirty water, is still the one that is being recycled, but it will go through powerful treatments. Are you there? More advanced treatment just on this concept too. So that's that for that. So that's that for that. That's that for that. Okay, and so on like that. Now let us now look at hardness of water. Should I look at that? Yes, let's look at hardness of water, please. Let's look at hardness of water real quick. Let me go to the next page. Hardness of water. Now, what do we call hard water? Hard water does not lather readily with soap. Lather means, when you mix soap with water, those foam that usually, those foam bubbles that usually get formed is what we call what lather. So hard water do not always produce lather with soap. I did not say detergent to soap, please. Soap. Okay. When you get to fat and oil in organic chemistry, you know the difference between soap and detergent. But remember, I said soap. Okay, let me give an example of those soap now. The one that you know. I don't know about, okay, we know B29. We know all those solid bar soap, B29, Okin, and so on like that. So all those are like solid bar soap. But detergent are like Good Mama, exactly. Good Mama. We have Wow, we have Magic, and so on like that. We have Viva. All those are detergents. All those don't lather with any type of water, whether it is hard, soft, or anything. Good. Okay, pay attention. Why is it that hard water don't lather readily with soap? Take note of something, guys, that hard water contains what we call calcium and magnesium ions. You see, these are the two ions that are responsible for hardness. Ions responsible for hardness. Responsible for hardness. Ions responsible for hardness. Exactly. These are the ions responsible for hardness. Good. Please don't forget to. Ions responsible for hardness are calcium ions and magnesium ions. Now, looking at hard water is divided into two. We have what we call the temporary hard water, and we have what we call permanent hard water. Now, everybody see, don't forget, both temporary and permanent hardness, what is responsible for those hardness are calcium and magnesium ion, but in different form. Now, pay attention. Look at these compounds. This compound that you are seeing here, CaHCO32, MgHCO32. You see these compounds are responsible for temporary hardness. You can see I still have calcium and magnesium ion there, but in form of hydrogen triisocarbonate 4. These are responsible for temporary hardness. Please don't forget all these things. They are very important too. But for permanent hardness, what are responsible? Permanent hardness, what are responsible are, check it out, CaSO4, MgSO4, CaCl2, MgCl2. You can see still calcium and magnesium are present, but in form of sulfates and chlorides. In form of what? Sulfates and chlorides. In form of sulfates and chlorides. So all these are permanent, all these are what? Temporary. Good. Okay, nice. Nice. So I believe all these concepts are clear. Hard water don't die directly with soap. The two ions responsible for hardness are calcium and magnesium ion. For temporary hard water, calcium hydrogen triisocarbonate 4 or magnesium hydrogen triisocarbonate 4 causes temporary hard water. Calcium hydrogen triisocarbonate 4, magnesium hydrogen triisocarbonate 4 are responsible for what? Temporary hard water. Permanent hard water, calcium and magnesium in form of sulfate and chloride. That's calcium sulfate, magnesium sulfate, calcium chloride, magnesium chloride are responsible for what? Permanent hardness. Good. So pay attention to removal of hardness. All these are important, please. Removal of hardness. How do we remove hard water, please? Removal of hardness. How do we remove hard water? Well, pay attention. Let's first see how to remove temporary hard water. Let's see how to remove temporary hardness, rather. Temporary hardness. Temporary hardness. Let's see how to remove temporary hardness. You see, first thing you should know is that what temporary hardness can easily be removed by boiling. You see, even if you want to forget anything, don't forget temporary hardness, sharp, if you boil it, it has gone. Okay, good. Let me show you something. Remember, this part of what's responsible for temporary hardness. Let me say I now boil it now. You remember, this is in hard water. In hard water is in the water. Don't forget that this guy is in the water. That's the temporary hard water. If I boil this water now, what is causing this temporary hard water? It will just decompose on heating to give me CaCO3, H2O plus CO2. Please pay attention to something. Don't forget that if you look at your kettle, you observe some substances being deposited. Isn't that the way you get your kettle when it was new is different from how it is now? Yeah, those color that you can see deposited in your kettle is as a result of the deposit of this CaCO3. And that deposit is what we call FOR in your kettle or your boiler. We call it FOR. Don't worry, we'll come to the effect of hardness. What you are going to learn here is that temporary hardness can be removed by boiling. And this is the equation to show that, wow, we have removed temporary hardness. Another one is that what? It can be removed by adding slaked lime. Can be removed with slaked lime. Okay, this slaked lime, everybody, CaOH2, this slaked lime, don't forget this slaked lime. So if I react it with this temporary hardness, what do I have? Well, it will give me CaCO3, then 2H2. You can see this hardness has been removed very fast. What is causing this hardness has been removed. So this one will now be deposited in your kettle to give you a 4. That's one of the effects. Your kettle will now be looking brown inside, kind of brownish inside, yeah, because of deposit of all this. Okay, we add washing soda also. We add washing soda. which is Na2CO3, then plus temporary hardness. You see the way to remove it. To remove it to CaCO3. Good. What you are just to know that JAMB will ask is that which one can be used to remove temporary hardness, permanent hardness, and this. So you are just to know, okay, temporary hardness can be removed by boiling, slake lime, washing, soda. Now pay attention to something. These are methods that are used to remove temporary hardness. But what about to remove permanent hardness? Now let me tell you a short story. To remove permanent hardness, please pay attention that any method that can remove permanent hardness automatically will remove temporary hardness. Again, any method that can remove permanent hardness will also remove temporary hardness. Don't forget, any permanent hardness will also remove what temporary what hardness. Are we together? Good. Okay, so let me just jot some of them for us here. So because of time, let us jot some of them for us here. Okay, just jot it, don't worry. Also, this washing soda can also remove permanent hardness. Washing soda can also remove permanent hardness. Also, distillation method by distillation can remove permanent hardness. Also, using what we call ion exchange resin. Don't worry, yeah, just to know it's like this. Ion exchange resin. Using ion exchange resin. Another word for this is Permutit method. This method can remove what permanent what hardness. Good. So if you tell me that temporary hardness can be removed by distillation, you are correct. Because a method that can remove permanent hardness will also remove what? Temporary hardness. Now, we have learned how to remove temporary, we have learned how to remove permanent. Now, the next simple thing we are going to learn is, let's look at disadvantages. Disadvantages of hardness. Disadvantages of hardness. And also advantages of hardness. Now, both of them have advantage and disadvantage. Now, pay attention. You see, advantage of water, one of the disadvantages that was is it wastes soap. It wastes soap because it does not lather easily. The soap will keep wasting, but it does not lather. Are we together? Yeah. Do you know why it does not lather? This is something. Check. You see, when hard water, when soap is used in hard water, instead of it to be producing lather, the foam that we need, it will first produce scum. It will first produce what we call what? Scum. Exactly. You see, one of the disadvantages of hard water is that what? It wastes soap by producing what? Scum. Are we together? Good. And you will see scum, if you are done with this, you can just type scum on clothes on your Google and go to the image. You see that there are some clothes that you'll be seeing some white substance on it like this. That is the scum as a result of the hard water. Good. Next disadvantage is that it causes fouring of kettles. Fouring of kettles and boilers. It causes what? Fouring of kettles and what? And boilers. Yes, all those deposits that is being deposited on your kettle and your boiler is as a result of the hard water. Okay, as a result of the what? Of the hard water. It's as a result of the what? Hard water. Wow. Okay. Okay, next one is that what? Hard water is not suitable. Is not suitable in where? Is not suitable in laundry or tanning. Hey buddy, you cannot use it in laundry because it will be producing scum on customers' clothes. Let me say, hey, please hold on. I forgot to plug this. Please hold on. I'm coming, please. Okay, good. Ahem. So, what is the meaning of the word tanning? Tanning is the process we use to convert animal skin to leather. The process we use to convert what? Animal skin to leather. The process we use to convert what? Animal skin to leather. So, hard water is not applied here because of the production of the scum. So, let's look at advantages of hard water. Advantages of hard water. What are the advantages of hard? Well, remember that I told us that hard water has calcium and magnesium ions. You see, these ions help animals like crab, snail to build strong shells. Yes. Also, hard water have this kind of better taste. Are you together? It has this kind of characteristic taste than, yeah, it has it very well than soft water. Okay, so it has a better taste. Also, we can say hard water is very useful in brewing. Because of this taste, is useful in what? In brewing. That is, in brewing industry, either to produce beer and so on like that. And because of this, remember I told you that this aeon helps animals like snails and crab to build strong shells. Also in human, it helps. Remember that what calcium is part of the nutrient that is needed to build strong bones. You understand? To build what? To build strong bones. Good. So it's useful for human also. And then, so that's that, and so on like that, and so on like that, and so on like that. Please give me a second. I want to. Now, first, okay, I've discussed advantage and disadvantage. Okay, let us now look at advantages of salt water. And I want this one to be interactive. Advantages of salt water. Okay, can someone tell us advantage of water that is not hard? Advantages of salt water.
Some
Okay,
easy ladder with soap.
it's formed ladder readily. So it means that one does not waste soap. Okay, another
It is
person.
better. It is used for cleaning.
I, yeah,
It's okay to go.
Okay, are we still there? Are we still there? I'm sorry. There was a network issue here. Yeah. So we are still here, please. I think there was a network failure here. Okay, let's look at water pollution. I believe you can still hear me. Let's look at water pollution. Okay. Now, when we say water pollution, remember, if I say a water is being polluted, what does that mean? It means that what there are harmful substances in the water. All together, there are harmful substances in the water. Okay, good. Now, you see, let me tell you something. There are some atmospheric pollutants. Pay attention. There are some atmospheric pollutants that have effects on water. Example, it has effect on rainwater. Remember, rainwater comes from the sky, which means that if I have any impurity in the atmosphere, it will contaminate the rainwater. Please, I believe we are still here, we are getting it good. There are some atmospheric pollutants you have to know. Example, look at them. CO2, SO2, NO, NO2, and so on like that. Let me add this, H2S. You see, the effect of these atmospheric pollutants is that they cause acid rain. They cause what? They cause acid rain. Yeah, they cause acid. Remember that they are dissolved in the air. And if you observe, all this that I'm listing here, they are what? Acid anhydride. That when you dissolve them in water, they produce acid. Exactly. Imagine they're in the sky and they'll contaminate the rainwater to give what we call what? Acid rain. Exactly. So this atmospheric pollutant causes acid rain. Good. Now, there are some wastes also. There are some pollutants also. We use this term for them. We say they are biodegradable. I'm just giving us some important points that we need. Very, very important. And some are non-biodegradable. Some are biodegradable, while some are non-biodegradable. What does biodegradable mean? It means that they can be decomposed by bacteria into harmful substances. They can be what? There are ways that can be decomposed. There are ways that can be decomposed. They can be decomposed by bacteria into harmful substances. Into harmless substances, into harmless substances, yeah. Yeah, biodegradable. Example, some refuse. Example, refuse, human waste, organic matter. Organic matter. Hello, mute your mic, please. So that's biodegradable waste. If there's what about biodegradable waste, there are waste that can be decomposed by bacteria into harmless substances. An example are refuse, human waste, organic matter. Okay. Hello, please mute yourself. I'm coming. Hello, Wiz. Are you Ajomale, please?
Ajomale.
Mute yourself now.
Ajomale. Ajomale, what is your problem now?
I'm muting here, don't worry. I'm muting here. Yeah, I've muted him already. So, atmospheric pollutants, acid rain, biodegradable. So, non-biodegradable cannot be decomposed by bacteria. Okay, are we together? Non-biodegradable, let me see. Non-biodegradable cannot be decomposed by bacteria, e.g., some industrial waste. Industrial waste like plastics, metal scraps, chemicals, dyes, All this cannot be decomposed by what? By bacteria. Also, some agricultural waste, like some chemicals that they use in the farm. Are you there? Agricultural waste. So all these are what? Non-biodegradable. Now, there are also some type of pollutants. You know, this pollution they call oil spillage. Oil spillage. Yeah, when crude oil is released into water, that's what it means. When crude oil is released into water, you see, there's a particular question they always ask. Let me say I have water now, and there's crude oil on the water. Please, what can be the effect of the crude oil on aquatic organism? The effect of the crude oil is that it decreases the amount of oxygen. Crude oil decrease amount of oxygen getting to the aquatic organism. I remember when there's no oxygen, what remains? The organism will start what? The organism will start dying. Exactly. The organism will start what? Will start dying. So there are different type of other ways too and so on, but these are very important for you to know. That's it. So this is the end of the lecture for water and water pollution. With this, read and understand it, then you'll be able to solve question, I believe. So that's that. Please, who have question to ask? Yeah. That's that. That's the end of the lecture. That's the end of the lecture. Who have question to ask? Who have question to ask? Okay, no one, Abi. Good.
Would you ask question?
Okay.
Sekina, ask question. Amarachi, ask question.
Sekina, ask question. Sekina, ask question. Oh, she's here. Sekina, ask question. We are waiting for your question.
She's here. Sekina is
Sekina has
Sir.
slept off.
Sir.
She has slept off.
no. Okay.
Yes. I can hear you.
Sir, about that disadvantages of hard water. You said
Okay.
that it cannot be used in laundry or tanning. I want to ask that, can it be used in dyeing and bleaching?
No, it can't. It can't. Why? Because of the formation of scum, because of those compounds. Because of those compounds, so salt water is the best. Hello, but wait, look at something. Salt water is the best to use. But I've seen some people do some dyeing processes here with well water. And well water actually, do you know well water is an hard water? Do you know that? Hello, that can be. Do you know well water is an hard water?
No, I don't know.
Yes,
Of course,
I know.
it's an hard water, yeah. It's an hard water, good. It's an hard water. Well water, spring, river, all these are hard water. But I still see them using it for dyeing. But the best to use is salt water. Yeah. The best to use is salt water. But majorly, where this hard water has more effect is in laundry. If you use water that is very hard for laundry, you observe that after you take the cloth, after it is being dried, you will see whitish substance. I don't know whether you have seen the stuff before. Whitish substance on the cloth like this. I've seen it several times. Aha, that's what we call scum. So and so on like that. So we have more questions to ask.
Sir, one more question.
Okay.
Sir, one more question.
Okay.
Sir, please, for that hard water, which kind of pipe, like, it says that it contains some elements in the water. So, like, what kind of pipe can someone use for hard water, like to pass hard water?
Pay attention. Get it well. It is salt water that have effects on pipe, not hard water. Hello, are we there? Pay attention. Which water has effects on lead pipe? Soft water. And that is why they always make this water that pass through pipe, they always make it hard. Like they always make it a little bit hard, so it won't have effects on lead pipe. Are we together? Hello, are we together?
Yes. Yes, sir. Yes.
Yeah, hard water don't have effects on pipes at all. It's these two normal pipes that you know. This normal pipe is this normal this normal lead pipe. Yeah, exactly. This normal lead pipe. So Salt water
Thank you,
have
sir.
effect on it. That's why, yeah. Yes. If you observe, the water that we pump, even the water that we pump from home, the one we pump, remember, it's coming from the ground. And something coming from the ground will have it will have, it will have some contact with some rocks. So that will make it hard. So it has no effect on those pipes, and that's it. Any other question?
Yes, sir. Thanks.
Yeah,
Sir?
yeah. Good. So no other question?
Sir, I have a question.
Okay, ask.
Yes, sir. According to this, this water pollution, I was wondering that why is it that water affects human health? Like
Water affects what?
human health. Why is it that water affects human health?
Water affects human health.
Yes.
It depends on the type of water you are taking. If that type of water that you are taking is contaminated, yeah, like someone that is taking water that is not treated, the person will surely have different things like diarrhea, cholera, and so on like that. So it depends on the type of water you are taking. Yes, if you are taking water that is not being treated well, then you'll be exposed to some, to some hazard, and that's it.
Okay, sir.
Yeah.
Yes, sir.
Which other person? Yeah. So I think
Mr. Salah, are we done? Mr. Mr. Salah, are we done? Mr. Salah, so I think the class has ended. So thank you very much for coming. See you guys tomorrow. Don't worry. All the sacrifice that we are making, by God's grace, we are going to repeat with a very high score.
Amen.
And not just high score that we gain, that will give us admission. Inshallah, by
Amen.
God's grace.
Amen, sir.
Amen. Amen, sir.
Amen. Oh.
Kilo day, are you
Amen.
in church? Amen. Okay, so see you guys. Go and rest. Please don't come to lesson late. I will be there as early as 7:12.
Okay, good night, sir.
Good night. Bye bye. Oju, bye bye.
Bye bye. Bye bye.
Oju,
Sir.
again now. Do that thing again now.
Uh,
Have you make your hair? Have you make your hair?
Who are you asking?
Kí ni mo ń béèrè word? Oju.
Okay.
Oju ṣo ti ṣe rán. Ó ti sá lọ. See you tomorrow, guys. Go and rest. Bye bye.
Hello, please. We are done with this class. You can leave. I have some set of students to teach. Yeah. Hello, please. You can leave this class.